This is the final test of 41487, which is a Parasound. Let's see if we get this down here a little bit. Get some light here. Which is a Parasound PL/LD-2000 preamp. Pretty well made item. Definitely not something most common people have. And what we're going to do is test this using some test equipment. And this test equipment, I'm going to turn the light off of this, is going to show us the left and the right channel, because over this microphone it's going to be difficult to hear it. The test equipment does a much better job of displaying it. The item in front of us is called a dual trace oscilloscope. My hesitation is the software fights me all the time. It's amazing. Just amazing. It's the software that the camera recommends, but my God. So I'm going to try to zoom in on this a little bit, show you what's going on. There we go. The upper display, two horizontal lines. The upper horizontal line is going to be the, someday we can afford a camera person. I'm going to turn this down a little bit so we don't get so much. There we go. It's probably easier to see. The upper display is going to show the left channel. Lower display is going to show the right channel. Also, there is a black horizontal instrument right there. You'll see two orange dots. That also is going to display the left and right channel in decibels. We're going to use that to measure frequency response. So I have tested all the inputs and outputs after the work has been done. And let's back this out a little bit. Go back down here. And the light has to come off because the camera does not pick up the oscilloscope very well when there's light on it. It's all glare. So what we're going to do is feed in regular audio into the balanced input. So what we're going to do is test both balanced and unbalanced. We're going to feed in initially just regular audio off of the FM tuner into balanced. Then we're going to go into auxiliary, which is unbalanced, and we're going to feed in sine waves, which is going to show us the low level of distortion, and we're going to do a frequency response test. So, yeah, that's a little better. So let's get this off a little bit here, and we're going to turn this on, and if I turn the volume up too loud, it may distort the microphone, and it may override my voice. But let's go and
every weekday at
take a look at the oscilloscope.
Hero Show on the Talk of Connecticut, WDRC.
The human capacity to go along with evil in order to justify
Oh,
our
yeah,
actions
oh boy.
is nearly endless. What we in Hebrew call teshuvah, right? We have to spend an enormous amount of time examining
Yeah, we'll get a
our
camera
intentions,
person
trying to
someday.
examine our own actions.
So I'm going to get the
and
light
things
off of
that
this so we can look at
it
the
should be a
scope.
good thing for any good person, whether you're religious or not religious. So
Ben Shapiro
And we're going to
Show,
zoom in a
weekday
little bit.
afternoons from 5 to 6.
I'll turn
on
this
the
down,
Talk of Connecticut,
and I'll zoom in on the scope. Then I'm going to pan from left to right and show you left and right works. But more accurately, when we go over to the sine waves, it will be a much more revealing test.
If I'm invited to a charity event about cystic fibrosis,
A little bit more here is
helping
good.
out foster kids, when I go, I leave my politics outside the door.
There we go.
9 to midnight on the Talk of Connecticut, WDRC, WSMG.
So I'm going to go to the left,
WDRC AM.
and you're going to notice that the right disappears on the oscilloscope and on the decibel meter. Then I'm going to go over to the right, and the left is going to disappear. We're going to put it back in the middle. And then what we're going to do is go to signal generator, and we're going to start at the very lowest. Yeah, sure. You can tell this is unrehearsed. We're going to go to the lowest audio range. Hello.
Selected to represent.
Well, I think we're going to have to do this over again because this isn't happening. Oh, there we go. Totally unrehearsed, folks. Yeah, it was a CD input, not auxiliary. So we're going to go to CD input, which we're feeding in signal generator, and this is extremely low frequency. It's about 20 or 30 hertz. So we can't hear it. And what I'm going to do is turn this down a little bit. So we'll set it right there. And we want to make sure that the left and the right do not change decibel-wise, maybe 1 or 2 decibels across the entire audio range. So what we're looking at, and I'll change the sweep speed on this a little bit, is that's what that sine wave looks like at this extremely low frequency. As I increase the frequency, the sine wave is going to, the period is going to become shorter as the frequency increases. Eventually, you might hear this. I'll turn the volume up a little bit. You might be able to hear that. Okay. You notice that the left and right decibels have not changed. We're going to go to the next higher range. Because we're at the high range, we start at the highest frequency of that range. Change the sweep. We're going to go down. You might be able to hear that. And you notice left and right have not changed. Looks like it's painted on. Very nice frequency response. Okay, now we're going to bring it up to the hearing range of dogs and bats. This microphone may not be responding, but the visual of the oscilloscope is telling. Right now we're at about, that's the 8K, that's 15K. How high can this go? That's 20K. And have not changed. Very, very nice machine here. So we're going to go back down here, and we'll go back to our audio.
Breaking news from the Talk of
And that will be the end of this demonstration.
And now, 103.3 FM.